Hello. We would like to present you the study SAT solver's effort to solve a Sudoku puzzle. Uh, First, we will provide you some introduction to the topic. Then we'll state our hypothesis. Then the results will follow, and we'll end up with some conclusions. So, as we all know, SAT solvers use propositional logic for knowledge representation and for solving satisfiability problem in propositional logic. Um, the Sudoku puzzle can be easily transformed into a propositional formula, and then a solution can be found using the SAT solvers. And our goal is to check what makes solving Sudokus hard for SAT solvers. In the study, we used about 12,000 clauses per puzzle. We investigated a sample size of 50,000 Sudokus, and for the experiment, we used one of the best solvers in the market, ZSHAF. As a variable, we used the number of givens in a Sudoku puzzle, and as a measure of effort, we used the CPU time. As an additional variable, we used the scattering of numbers of givens um, as, as a metric of the reliability of the spread of the givens per block. So here's our hypothesis. The number of givens has an influence on the effort of SAT solver to solve a Sudoku puzzle. And the intuition behind the hypothesis is, as Jones showed in 2011, the lower number of givens in the puzzle, the bigger search space of the SAT problem, and the higher number of givens, the smaller search space.
Hi guys, I would like to talk about the results that we obtained. Well, despite of our enthusiasm about the hypothesis, we came to the conclusion that we couldn't find any correlation between the number of givens and the CPU time. So when we look at the scatter plot, we see that there's no trend. There's the number of givens doesn't influence the CPU time that the solver needs to solve the puzzle. Further, we look into the scattering of the givens across the board, and with respect to the CPU time, and likewise, we couldn't find any trend. Even more, we saw that most of the puzzles are solved within a time of 0.0004 seconds. We also noticed that most of the scattering of the givens across the board is relatively uniform. They are the givens are spread over the board in the different blocks with a scattering ratio of 2. So on top of that, in terms of the statistics of our metrics, we found that the CPU time in average is 0.0004 with a standard deviation of 0.00007, which means that the CPU time deviates from the mean very little. Most of the puzzles I already said get solved within a very small time, so we don't see much variability on effort. And the scattering, as we already said, is most of the puzzles, or 75% of them, have a scattering of around 2. So we observe some outliers. Some of the puzzles get solved within 0.001 second, and some of the puzzles have a scattering ratio of 6.46. Well, our conclusion after this study is that there is not enough evidence of the validity of our hypothesis. Perhaps we think that different factors could have influenced this result, like database bias. With that, we mean that, okay, we extracted our Sudokus from one single location, so We don't have control over the algorithm that they use and how they define the difficulty of each puzzle and which criteria they use for that. So the Sudoku size is also 9 by 9, and as we already saw, there's not enough variability in the results, and the amount of givens with respect to the number of closes it's very small. And as a consequence of that, such number of constraints cannot generate enough variability of the results. In the future, we would like to investigate different encodings, larger Sudoku grids, extended encodings, not only the naive one as we did, and the encoding of heuristics. Thank you very much.